Hello and welcome. Today we're going to be covering 9.1, our first section of Chapter 9, which is on scatter plots. Under our key idea, we can see that a scatter plot is a graph that shows the relationship between two data sets. The two sets of data are graphed as ordered pairs in a coordinate plane. Graphing in a coordinate plane is not something that we have yet discussed together, but you have learned it in previous courses. In example 1, the scatter plot at the left shows the amounts of fat in grams and the number of calories in 12 restaurant sandwiches. So when we're reading this graph, this bottom line here represents the number of fat in each sandwich, and this vertical line, or this vertical axis, represents the number of calories in the sandwich. For example, if I go up to 10 grams of fat, I can go up to my first sandwich here and see that it has approximately 410 or so calories. If I went to this sandwich, it would have maybe 16 or 17 grams of fat, and then I go up to about 400 calories. In part A, we want to know how many calories are in a sandwich that contains 17 grams of fat. Well, that was the one I just pointed out. If we go a little bit past 15, and then find the dot that has that value, I go up and see that it has about 400 calories. So for part A, I'll say about 400 calories. In part B, how many grams of fat are in the sandwich that contains 600 calories? So now I'm going to start on the calorie axis and go up to 600. So I know it's got to be somewhere along this horizontal line, so I go along to the right until I hit the dot that is on that line. Here it is. And then I need to go down to see that it has 30 grams of fat. So in this sandwich, there are about 30 grams of fat. In letter C, what tends to happen to the number of calories as the number of the grams of fat increases? So as these numbers go up along our horizontal axis, as the number of fat goes up, we can see that the dots rise upwards as well, meaning that as the amount of fat increases, so does the amount of calories. So the number of calories increases. This is what we call a positive relationship. As the fat increases, so do the calories. They both go up. What if a sandwich has 650 calories? Based on the scatter plot in example 1, how many grams of fat would you expect the sandwich to have? Go ahead, take a moment, look at the graph, see what you think. If I'm looking at this data, 650 calories is about here. If I'm following the upward trend, I would expect it to have right about 36 grams of fat. There should be a dot maybe right about here or so, but I would say between 35 and 40 grams of fat. So 35 to 40, and that is close enough. We don't know exactly, we're just estimating. So 35 to 40 grams of fat. A scatter plot can show that a relationship exists between two data sets. For example, this first one looks very similar to our last example. We say that that has a positive and a linear relationship. The dots seem to follow a straight line. That's why we call it a linear relationship. And positive because everything is rising. However, in this second data set, we call this a negative linear relationship. Again, the dots all seem to follow a straight line, but they all decrease as we move forward in our graph. Third, we have a nonlinear relationship. So if I tried to follow the trend of these dots, I would see that that is not a straight line that these dots are following, so it is nonlinear. And lastly, no relationship. Your dots are all over the place. They're not positive or negative. There's no trend that these dots seem to follow. In example 2a, I'm going to describe the relationship between the data. I need to identify any outliers, any gaps, or any clusters. So looking at A, I would say that this is a pretty positive relationship, and I would also say it's linear. So it has a positive linear relationship. Identify any outliers. What that means is, are there any dots that seem kind of random, maybe like they don't belong? They're lying outside of the normal trend of data. If we look at this chart, this dot right here does not seem to belong. We can write that as an ordered pair, where the television side, this x-axis goes first and the y-axis goes second. My value in television size is 70 inches. So I have 70, comma, and then go up to the y value. This dot went up to about 2250, it looks like. There's my ordered pair. And I will say that point is an outlier. Any gaps, so any spaces in my data, I would say right about here, there is a gap. Between, and we usually talk about x-axis, so I am going to see where does my first x in this gap start. So that would be maybe about 32. And then my next dot isn't until 40. So there is a gap between 32 and 40 inches. And then any clusters, same thing. Here are my clusters. All the dots are pretty close together. So there is a cluster between the first dot in that cluster is at about 25 inches, and then the last dot is at about 32. So 25 and 32 inches. Go ahead and take a moment to pause the video and try the next part B on your own. In part B, this one is deceivingly easy. These dots have no relationship. They are just all over the place. That being said, there's really no outliers because there's no relationship or no trend to follow in the first place. They're so spread out, there's no gaps or no clusters in the data. So all we can say about part B is that there is no relationship. For our last slide, we are going to make our own data plot and then proceed to identify the relationship, outliers, gaps, and clusters like before. So in my scatter plot, I'm going to draw my y-axis and then my x-axis. This y-axis represents the test scores. That can be seen from the chart. And then study time is my x-axis. Labeling can get a little bit tricky. Looking at my study time, I see that my smallest value is 10 and my biggest value is 120. So I'm probably going to count by tens from 10 to 120. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. For my y-axis, I see that my smallest value is 62, and my largest value looks to be 97. So I'm not going to number from 1 to 62. I'm actually going to skip a whole bunch of numbers. So down here in my graph, I can draw this little symbol that says I'm going to skip a whole bunch of numbers and start at 60. And then from there, it might be a good idea to count by either 2s or 5s. I'm going to go ahead and count by 5s. So 60, 65, 70, 75, 80, 85, 90, 95, 100. And now we plot our data. My first point is that x is 30 and y is 80, so I go right to 30. Here's 60, 65, 70, 75, 80. Here's my first dot. Then I've got 20 and 74. So right 2 to 20, 74 is right about here. I've got 60 and 92, 10, 20, 30, 40, 50, 60, up to 92, which would be right about here. 90 and 97, 20, 30, 40, 50, 60, 70, 80, 90, up almost all the way to the top. 45, 85 would be right about here. 10, 62, 30, 83, 75, 90, 120 and 70, and then 80 and 91. Looking at this data, it looks like it's got a pretty consistent positive linear relationship. I can draw a line going pretty much through most of the data. So I'm going to call this a positive linear relationship. For our outliers, this point here does not seem to belong in the data set. So I am going to say that there is an outlier at the point where x is 120, and then to the right I can count to see that y is 70. X is 120 and y is 70. For our gaps, so next I'll do my gaps. Looking at my data, there seems to be a gap maybe right about here. It's not a huge gap, but it definitely could be considered a gap. So I'll say that there is a gap between 62 and 70 on the y-axis, which is test scores. So 62 and 70 in scores. And lastly, in regards to clusters, when I look at this data set, I don't really see anything that's bunched together really close. So I'm going to go ahead and say that there are no clusters in this data set. Okay, that's all I've got for you today. Thanks so much for watching and have a great rest of your day.